So today's video is about, or is the first of our discrete distributions that we need to be aware of. The main focus of our statistics course are with two types of distributions. One is discrete, remembering discrete being things that we can count. So the numbers we'll be using will be countable numbers. So 2, 3, 8, 200, but definitely all countable, compared to what we're going to look at in a further topic are continuous distributions, and we're going to look at one particular type we're going to be focusing on. To introduce today's discrete one, we need to be aware of a probability distribution called the Bernoulli distribution. Now, in grade 11, we did a bit of a study on probability distributions, and you might remember that we would often have a table of values similar to what we have down here. This is a very short table. We had some large tables. You might remember some of the rules about those tables, where the sum of all the probabilities had to be 1, and all our probabilities had to be between 0 and 1. So let's get into that. We'll be revising our other rules for expected value and variance as we go in. So I'm hoping that some of these things will come back to you quite quickly, because we did do a bit of repetitive practice back in grade 11. So, our Bernoulli distribution. It's named after a person, Jacob Bernoulli, who came up with this concept, obviously a long time ago. So in many probability situations, there are only two possible outcomes. Now, it might seem there's not. I mean, it's quite clear in these scenarios. But maybe when you're starting to consider taking a card from a pack, often it's not about all the different things that you have to choose from in the pack. It's more about what you're looking for. So a good example would be, say, drawing an ace from the pack. And then if that's what you're interested in, there is only one other alternative to getting an ace, and that's not getting an ace. So often what we think we can't restrict to two possible outcomes, we find that we can. So when we do have two possible outcomes, it's called a Bernoulli trial. So we tend to call the two different possibilities a success and a failure. And the probability of success and the probability of failure don't change. So we actually have independent events. Doesn't matter how many times you will do the same experiment, you're going to get the same answer. So because of that, P and Q will stay the same. And always, because we only have two possibilities, when we add the two probabilities, and these letters P and Q are used throughout this topic. Okay? I can't say why we use P and Q. Maybe we probably use P because it's a probability, and Q is just another letter that's close to P in the alphabet. But we can see that their sum is always equal to 1, and we know that the sum of all probabilities in any distribution has to equal 1. It's just that we have two of them. So our successive trials, and as I described before, have to be independent. Doesn't matter how often you do them, the probabilities stay the same. So what that will mean is that the probability, because we only have two options, we've put them down as a 0 and a 1. It's very useful. You can see this is binary applications where you can only use numbers between 0 and 1. So let's just assign the 1 to the successful one. So that's P. And then the failure would be 1 minus P, or Q. Notice up here, Q is always going to equal 1 minus P. Now some texts will write Q as being equal to 1 minus P. Or they'll either write Q or they'll write 1 minus P. They mean the same thing. All right, now the mean of a discrete random variable distribution is referred to as, now we said called this the expected value in the past. And we've used the letter capital E to represent that. We could also use that symbol mu. And we use that for the mean. So our expected value of x, now that's our rule from last year. It's the sum of the probabilities multiplied together by the x value. So in this case, our x value is r. So we're going to need to add together two different things. The first one will be 0, and we're going to need to multiply it by 1 minus p, the probability. And then we're going to have to add the next one, which is 1, and our probability is p. So just directly from this table, we've done that. 0 times 1 minus p, and 1 times p. And we've just added them together. Okay, so if we simplify that, multiply anything by 0, we get 0. So expected value is equal to p. Now, you might remember the term variance, at least using the term variance, even if we don't remember what it is. Let's write that in. So that's our standard deviation squared, back from grade 10 work. Or we can write it as VAR, and we notice our capital X, and that's also from before. It's really important that we write a capital X, because X is the number, or X is whatever our variable is going to represent. Okay, so let's come back to here. So our variance and our standard deviation. And commonly we just use the term, well, we use the symbol SD, or we'll use our sigma sign. And that's our little sigma sign. So not our capital sigma sign that we use for totals. Now remembering our standard deviation and our variance aren't measures of centre. They're going to be like our mean, or our expected value is what we're expecting to happen. It's the middle, all right? But our variance or standard deviation are measures of spread, how spread out our distribution is. So let's go ahead and calculate that. So it's the expected value of x squared minus the expected value of x. Try and get this so it's not doing this stupid thing anymore. That might fix it up. Sorry. So our expected value of x squared minus expected value of x squared. So if we're finding the expected value of x squared, it means that the sum we're doing is now with x squared. So we're going to have our x value from our table, which I don't think we can quite see here, but it was 0 for the first term, and we'll have to square it, and we'll have to multiply it by the probability, which was 1 minus p. So that's the first term. Then the next term, x was equal to 1, so we'll have to square it, and we'll have to multiply that by p. And then we're going to have to take away, so that's the expected value of x squared. Then we'll have to take away the expected value of x being squared. Now we calculated the expected value of x above. It was equal to p. So if we square the p, that will be our final term. Expected value of x squared is p squared. So just coming back into that, we've got 0 times something, which is 0, plus 1 times p, which is p, minus p squared. We could leave it like that, or we could write it as p times 1 minus p. And we know that 1 minus p is exactly the same as q. So we could write that as p times q. So our variance, that's our variance. So our standard deviation, remember that our variance is just our standard deviation squared. So we'll just need to find the square root of our variance to get our standard deviation. So I'll write that down. It's our variance, square rooted. So we have to find, it'll be the square root of P1 minus P. Now, quite important with all our probability, whether it's variance, standard deviation, it is conventional to round to 4 decimal places. So we'll, unless of course you're told otherwise. So we'll try and keep to that. I'll do example 1 as well. It's quite straightforward. What is most important about this Bernoulli distribution? It's not very useful by itself, because this is always about one event, and often it's not about one event. We want multiple things to happen. So we'll go through this. This is not our focus of the course, but it really is important in leading to our focus of our course. So we've got a new cream that's been developed for the treatment of dermatitis. In laboratory trials, the cream was found to be effective in 72% of the cases. Heng's doctor was prescribed the cream for her. So we're going to let X, we're going to write down what our variable is. It's the effectiveness of the cream. So when it's effective, we've got to draw up a probability distribution table. Effectiveness is 72% of the time. So we'll write 72% in there with the 1. Which means that for 1 minus P, that's going to be 0.28. So we've actually got our probability distribution table for X. Notice we're using the letter R in here. You can use a small x if you wanted to, and that would be fine. I think our formula sheet later on, when it comes to probabilities, we'll be using an R, which is why that's there. Okay, so we've done part A. Let's have a look at part B. We've got to get the expected value of X. So remembering, this is just the sum of our values. X times P, that X is equal to X. Maybe we're thinking of it as sum of R's times the probability that X equals R. Might make more sense. So we're looking at summing, oops, I don't need to write that sum sign, so we're just going to add them. 0 times 0.28 plus 1 times 0.72, which is going to equal 0.72. Now, this working is not necessary here. This is me trying to remind you of what our expected value of X formula was. But you could just write down 0.72 because with a Bernoulli distribution, that's our rule. Looking back here, that is always going to be true. The expected value of X is equal to P. Okay, so now we've got to get the variance and the standard deviation. So finally, now I'm not going to work through this one. Let's just use our rule. The variance is just P times Q, or 1 minus P times P. So we're going to have to multiply 0.28 times 0.72, and that is going to equal, I've got the calculation here, which I've done previously. So it's just a matter of grabbing the calculator out. That comes to 0.4490. So our standard deviation of X will be the square root of that, which I haven't actually calculated before. So, sorry about that. We can go to our calculator now at 0.449. So that should be nice and simple. Feel free to stop the video now. I'm just going to calculate that and write it in. It'll be in our notes. So we just want the square root of 0.4494? I'll squeeze back, 0.4490. That will do. So we're getting 0.6701. 0.6701. And we're done. There's a little bit of practice here to do. Yes, I can count, so please do them in the order that's specified here. It probably indicates 8 will be simpler than 6. Anyway, good luck with that. See you in the next video.